Cellular respiration, simply think about the word respiration is breathing in and out. Respiration. So when you say cellular respiration, it's still that concept as well. The simplest way we define cellular respiration is harvesting ATP from glucose. So the purpose of cellular respiration is to harvest ATP, is to get ATP, adenosine triphosphate, which is the currency we use for energy, from glucose. Now, and that is done by breathing in and breathing out. So that's what we'll be looking at this evening, how we harvest energy through cellular respiration. So plant and animal cells break down organic molecule by cellular respiration in the mitochondria. And I'll talk about that. The chemical energy in food is transforming into chemical energy in ATP. So you see that? So your food that you're taking is converted into ATP. Key thing about cellular respiration is that it requires oxygen. And since it requires oxygen, it involves the mitochondria. That is the guy responsible for oxygen in your cell. All right. So if you look at this, you see that carbon dioxide and H2O will be used to produce glucose through photosynthesis. So they undergo photosynthesis and produce organic molecule, which is glucose. You are going to breathe in oxygen. So they give you organic molecule and also let out oxygen as their byproduct. You are then going to eat the food and also breathe in the oxygen, and then in that process generate ATP. And then you are going to breathe out CO2, and the CO2 is what goes to plant again, and plant use it to do photosynthesis. So it's a cycle. All right. Now, energy is going to enter this ecosystem as light, and then it's going to leave as heat. If you still remember, you go back to look at this chapter 8. You see when I talk about first and second law of thermodynamics. I talked about that the first law of thermodynamics say that energy can be converted from one form to another, but cannot be destroyed nor created. And I told you that the second law states that in the course of conversion of energy from one form to another, it is lost to the environment. And that's what you see here. That energy is going to enter the ecosystem as sunlight, and it's going to leave as heat. And you want to think about it, how you put gas in your car, and the car is going to generate some heat. That heat that is generated in your engine is lost. It's not used to do anything. It's just lost. That is what we talk about. So anytime, so like now, I've been going back to classes. It means I am burning some calories. I'm breaking down the glucose that I've eaten. And in the course of that, I will sweat. Heat is produced. And that heat is not used for anything. It is just lost to the environment. So that's what the second law of thermodynamics explains, which is what you see here. Now, the chemical elements are essential to life. They are recycled. Then photosynthesis is going to use the CO2 that you breathe out and water to make organic molecules. And then they are going to breathe out CO2, oxygen, which is their waste product. And then you take in the oxygen they breathe out and the organic molecule they make, and then you use it to make ATP. And then you breathe out CO2, and H2O will be used again by plants, and the cycle continues. All right, so catabolic pathway release stored energy. Again, is an emphasis from chapter 8. When you catabolism will release energy. anabolism attract energy. So in chapter 8, I told you that catabolic reaction are also hexagonic reaction because they are going to release energy to the environment. And I told you anabolic reaction are the same thing as endogonic reaction because they are going to absorb energy from the environment. So energy transfer from food molecules to other molecules play a major role in this pathway, and this process is central to cellular respiration. All right, now the breakdown of organic molecule is hexagonic reaction, which is what I just explained. And fermentation is a partial degradation, of sugar molecules without oxygen. So what we call fermentation does not require oxygen. I'm going to talk about each of the stages of cellular respiration later. And so what we call cellular respiration require oxygen. Fermentation does not require oxygen. So aerobic respiration consumes organic molecules and oxygen, and then it's going to yield ATP. So this is the process we are talking about. We breathe in oxygen and use that with the glucose inside of us to make oxygen, to make ATP. And ATP is adenosine triphosphate. I'll type that here so that you can trap it. So it's adenosine triphosphate. Now, whereas anaerobic in biology, when A comes before an existing word, it changes it to an opposite. So aerobic require oxygen, anaerobic does not require oxygen. So anaerobic respiration is similar to aerobic, but it consumes compounds other than oxygen. It consumes compounds other than oxygen. All right, so cellular respiration include both aerobic and anaerobic respiration, but it's often used to refer to as the aerobic process. There, I would talk about each of the stages and show you the one that require oxygen and the little portion that does not require oxygen. So although carbohydrate, fats, proteins are all consumed as well, it is helpful to trace cellular respiration with the sugar glucose. So usually fats will give you energy, and I think I may have told you that carbohydrate, when we were on chapter 4 and 5, I told you that carbohydrate gives you energy readily. But when carbohydrate is not available, then fat is going to give you energy. Fat gives you more energy, but fat only gives you energy when carbohydrate is not available. All right? So this is the general formula for cellular respiration. This is organic compound, glucose, combusted by inflow of oxygen that you are breathing in. And then you are going to breathe out CO2, and then water is formed. And the major thing that is produced, energy is released. So this is an hexagonic reaction because it's releasing energy into the environment. And of course, it is also catabolic reaction. So catabolic pathways do not directly power work in the cell. They are linked to work by ATP. Cells must constantly regenerate their supply of ATP from adenosine diphosphate and phosphate. What does that mean? So, of course, I talk about this in chapter 9 or chapter 8 rather. When you use ATP, ATP is used by breaking down the terminal phosphate there, which is called the terminal phosphate, which is called so the terminal phosphate that is on the ATP triphosphate. So the third phosphate is what is removed anytime you are using energy. So what gives energy actually is that the ATP is going to release one of the phosphates, and then one of the phosphates will then phosphorylate a protein as though powers a protein. Then it's going to remain 2 ATP. So let me see if I can just make an analogy of that again. I knew I have done it in chapter 8, but I'll try. So this is ATP. So you have ATP here, and this is adenosine. Then you're going to have 3 phosphates. One phosphate, another phosphate. Oops. This thing will not let me do this. So another phosphate, I'll just do this way. Then another phosphate. So this is what we call adenosine triphosphate. All right. So we have adenosine triphosphate. There are 3 phosphates there now. Now, what happens when you give out energy is that this last phosphate will be removed. Then it will go ahead and power one protein that is meant to perform an action. So let's say lactase is supposed to break down lactose. So this phosphate is going to go ahead and bind to the lactase, which is the enzyme. Then the enzyme becomes active. That is the way enzyme works. ATP works. Now, when this phosphate has gone, then it's going to remain just one phosphate, 2 phosphates. So that's going to be called adenosine diphosphate. The adenosine diphosphate then will be in the system, and we need another phosphate so that it can become ATP, adenosine triphosphate. So you get food sources of phosphate, and that is the process that actually happens here in cellular respiration. How the ATP will be coupled with phosphate so that it become ATP again. All right, so let's go. So the transfer of electron during during chemical reaction releases stored energy in organic molecule, and that is what is going to be used to make ATP. Chemical reactions transfer electrons between the reactants called oxidation reduction reactions or redox reaction. It's more like you are saying you want to perform something in downtown, and you have to make some calls so that you can initiate an action in downtown even though you are not there. That's almost like the same way that cellular respiration happens through electrons. ATP are produced, but they are produced through electrons. Think about it as 2 signals. So somebody can just be acting. You see, the president may want to do something in a state now, and he doesn't need to get to that state. He just needs to make a call to the governor, or he just needs to send a mail to the governor, and then all he needed will be done just through sending of signals. So the same way, there are some signals that will be saved, which we call electrons. And those electrons is what are the ones that will power the generation of ATP. So sugar itself necessarily may not get to some stages. It just needs to send a message through the electrons. So you'll be seeing, as we go, we'll be seeing how the electrons are generated. And we'll be seeing how the generated electron can foster the production of ATP. Those are the things we'll be looking at as we go. So now, what do we call redox reaction? Redox reaction means reduction and oxidation. So redox came from the word reduction and then oxidation. Now, so you have the word oxidation and then reduction, and that's where we came across redox reaction. Now, I'm going to talk about both of them, and I don't want you to forget. So number one, what is redox reaction? Or what is reduction and what is oxidation? Reduction simply means removal of oxygen. So I would define them in terms of oxygen, in terms of oxygen, in terms of hydrogen, and in terms of electrons. So number one, reduction means removal of oxygen, and then oxidation means addition of oxygen. I expect that you are making your notes. So reduction means removal of oxygen, and oxidation means addition of oxygen. So when an oxygen has been when the oxygen is removed from a substance, we say the substance has been reduced. When oxygen is added to a substance, we say that substance has been oxidized. So when a substance loses oxygen, the substance has been reduced. When a substance gains oxygen, the substance has been oxidized. So if you look at this instance now, again, in terms of oxygen, I'm defining it based on based on oxygen, based on hydrogen, and also the third one will be electrons. So number one, based on oxygen, oxidation means addition of oxygen, just like the word oxidation, addition of oxygen. Whereas reduction means removal of oxygen. So if you look at this equation, for instance, now, if you look at this equation, now, this substance here is actually what became carbon dioxide here. And this here is what became water here. So if you compare this glucose and the carbon dioxide, which of them have more oxygen? How many oxygen does glucose have here? Glucose have 6 oxygen here. O6 means 6 oxygen. Whereas when you come here, oxygen here, this is 2 times oxygen, then times 6. Oxygen here, there are 12 oxygen here. So that means glucose has been oxidized to form carbon dioxide. So this reaction has undergone oxidation. So this is oxidation here. Does that make sense? I was watching your responses. I didn't get any response. Does it make sense?
Yeah, sorry, I gave a thumbs up.
Oh, great. Thank you. Now, when you come here, thank you. When you look at this, oxygen here, there are 12 oxygen molecules here because 2 times 0 times oxygen, O2 means 2 oxygen. Then everything times 6 means 12. There are 12 here, but by the time it gets here, we only have 6 oxygen. So that means oxygen has been removed here. So it means oxygen here has been reduced to hydrogen, to water molecule. So this reaction here, it's a reduction reaction. So number one, I have defined it in terms of oxygen. Number two, in terms of hydrogen. Reduction is addition of hydrogen, and oxidation is removal of hydrogen. So if you look at this, again, reduction in terms of oxygen, in terms of hydrogen, is the addition of hydrogen, and oxidation is removal of hydrogen. So if you look at this now, this here we have 12 hydrogen here. But by the time we have gotten to this side of the game, hydrogen has been totally lost. So has this been oxidized or reduced? Again, here, hydrogen, there are 12 hydrogen here. But by the time it came to the product side, hydrogen is completely lost. Has this glucose been oxidized or it has been reduced in terms of hydrogen? Okay, so this has been reduced. It has been oxidized because hydrogen has been removed. Because we know that reduction is addition of hydrogen and oxidation is removal of hydrogen. So since hydrogen has been removed, it is reduction, it is oxidation. If hydrogen is reduced, if some of it is gone, it is also reduction, it is also oxidation. So if hydrogen is totally lost or it is partial removal, it is still oxidation. So let's look at this as well in terms of hydrogen. Here there's no hydrogen here. But by the time this came to the product side, hydrogen has been added. As a matter of fact, 12 has been added. Has this been reduced or oxidized? Because hydrogen has been added, it has been reduced. Those are the cases of reduction and oxidation in terms of hydrogen and oxygen. Now, the last one I'm going to talk about is in terms of electrons. I'll say general rule now, and I'll be talking about it later. In terms of electron loss or electron gain, oxidation is, now let me start with reduction. Electrons are negative. So when you get a negative, have you increased or reduced? If you get a negative, have you become increased or you have become reduced? When people get negative, it's more like you spend more credit card. Have you become richer or poorer? You have not become richer by getting more credit, by spending more credit card money on this credit card. You have rather become more negative. So getting more negative makes you become reduced. So addition of electrons or gain of electron is reduction, whereas loss of electron is oxidation. So I'll take the three definitions now. In terms of oxygen, oxidation means addition of oxygen or gain of oxygen, whereas reduction is loss of oxygen. In terms of hydrogen, gain of hydrogen is reduction, loss of hydrogen is oxidation. In terms of electron, gain of electron is reduction, and loss of electron is oxidation. So those are the three definitions when it comes to oxidation and reduction. Now, let me show you something very interesting before we continue. So this is redox reaction here. If you look at this, if you remember now from chapter 3, I had noted when we look at water, we look at acid, base, and buffer. When you see this, actually, it's a proton. And when you see this, its electron. Now this is actually going to give rise to hydrogen. And the concept is simple. It's like +1 plus -1 is going to equal to 0. That's more like what is on there. So the +1 is H plus, E minus, then it cancels out and give you hydrogen. So now the rule is this. There's a rule that anytime electron falls, heat is released. Anytime a substance is converted from one form of energy to another, electron will be lost. And anytime electron is lost, heat is released, which is what gave rise to the second law of thermodynamics that says anytime electron is converted. So this is what we call the heat, the proton. And this is gone with it. So anytime electron falls, heat follows. So electron, H plus is the heat, and that's going to produce what we call hydrogen. All right. I'll come back to this later, so please take note of that. So H plus plus E minus give you hydrogen. So that means inside hydrogen, there's proton and there's electron in there. And that makes sense, right? There's one electron, there's one proton inside one hydrogen. All right. Now, let me show you. Again, oxidation is loss, reduction is gain. This is when we are talking of electrons, right? In terms of electron, oxidation is loss of electron, reduction is gain of electron. Oxidation is loss of hydrogen, reduction is gain of hydrogen. Oxidation is gain of oxygen, and reduction is loss of oxygen. All right, let's go. Now, I want to look at this and show you this from this equation. Now, looking at this equation, glucose was the one that became this. Let me use the annotation here. So glucose gave rise to this. If glucose gave rise to this, that means this actually was was oxidized to become carbon dioxide. If this was oxidized to become carbon dioxide, then that means if there are two partners here and one of them became oxidized, that means it's the other partner that oxidized it. This cannot oxidize itself. It would have only been oxidized because somebody has oxidized it. A car should not move by itself except somebody moved the car. So if this guy became oxidized to become CO2, it means something oxidized it. Now, what oxidized it is what we call the oxidizing agent. So this right here will be the oxidizing agent. Because if glucose is oxidized to this, that means something oxidized it. So that is called the oxidizing agent. Now, if we also look at this oxygen and we say it has been reduced to H2O, that means something also reduced it. So what will have reduced it? Because there are also two here, that means this glucose was also the reducing agent that reduced this. Because if you think about it in the real concept, now we say that glucose have lost some some hydrogen, and it has become oxidized. But who took the hydrogen from it? This guy actually took the hydrogen and gave it to form a larger molecule here, to form water here. So it is oxygen that oxidized carbon, that oxidized glucose. And it is also glucose that oxidized, that reduced oxygen. So that is the concept of reducing agent. So oxygen is going to be the oxidizing agent here. And glucose is also going to be the reducing agent that reduces oxygen to form H2O. So oxidation and reduction always go hand in hand. Anywhere you see oxidation, there's reduction. If there is front, it's because there's back. If there's no back, then there can't be front. So oxidation and reduction go hand in hand. The electron donor is called a reducing agent, and it's the one that reduces the electron acceptor. I'll still show that to you as we go. The electron acceptor is called the oxidizing agent, which is the one that oxidizes the electron donor. Now, instead of fully transferring electrons, some redox reaction will change electron sharing covalent bonds. I'll talk about that more as we go. Now, oxygen atom is very electronegative. We've learned that already. Oxygens are electronegative. And that's why we say they have high electron affinity. So they share electron in a partial way. And that's why they form polar compound with hydrogen to form water molecule. So they attract electron and they do not share them equally. You see that? They share unequally, which is what we call polar covalent compound. The partial gain of electron by oxygen atom and the partial loss of electron by their bonding partner in this, which can be hydrogen, which is also a bonding partner, right? Can be hydrogen, it can be potassium, constitute what we call redox reaction in terms of the way they reduce and oxidize. An electron loss potential energy when it shifts from a less electronegative atom towards a more electronegative atom. Now, the redox reaction that move electron closer to electronegative atom release energy. I'll show you all of that when we approach it. Okay, so this is cool now. So during cellular respiration, fuel such as glucose are oxidized. And what do we mean by oxidized? It simply means that you breathe in oxygen. When you breathe in oxygen, they get oxygen, and that's what we mean by oxidized. Addition of oxygen to them, oxidation. So addition of oxygen to your glucose is what is called oxidation. All right. Now, during cellular respiration, fuel molecules are oxidized and O2 is reduced. Now, think about it. All right. So think about it. All right. So think about it this way. During cellular respiration, fuel molecules are oxidized. So you breathe in oxygen. So let me show you this. I think I had, okay. So you bring in these now. You breathe in this oxygen. I'm moving quite slow because I want you to understand the concept. I don't want to rush it. I want you to understand it. So please follow me carefully as I'm going slow. You eat food. You eat pasta, and so you have this already in your system. Or let's say you had yogurt, and yogurt have lactose. The lactose is broken down into glucose and galactose, and now you have the glucose as source that your cell can harvest ATP from. So the glucose is sitting right there. But the glucose by itself does not give energy. It only gives energy when it's broken down by breathing in oxygen. So you breathe in oxygen when you were breathing. And you know the reason they say that we burn calories, you burn glucose when you exercise, is simply because you breathe in more. What is causing you to break down glucose when you exercise and you say you have burned your calories? It's not the exercise you're doing, it's actually because you are breathing in more. And so you notice that when you're on your treadmill and you are tracking your heartbeat, you notice that when your heart rate goes higher, you see that the calorie you burn also systematically increase. Now that is all because you are breathing in faster. At that rate, you are also burning calories faster. Now, so it is breathing in that we say that we add oxygen to this glucose. So we say the glucose has been oxidized by getting oxygen that you breathe in. When you now oxidize glucose, what does it become? It will become CO2 that you breathe out. So the glucose is what generates the CO2. Now, so we say the glucose has been oxidized because now at the end, you are going to say the oxygen number has increased from 6 to 12. Hydrogen has been totally removed, which is also oxidation. There's no more hydrogen here, and removal of hydrogen is oxidation. Now, the same thing when you come here, you see that the oxygen here has become H2O, meaning that hydrogen has been added to it. If hydrogen has been added to it, that is reduction. And then oxygen here was 12, now it's 6, again, reduction. Let's go. Now, so organic molecules with abundance of hydrogen are excellent source of high energy electrons. Cellular respiration is a redox reaction. Energy is released as hydrogen and electrons are transferred to oxygen atom. Let's go, I will be explaining that. Now, so the oxidation of glucose transfers electron from a higher energy state in glucose to a lower energy state with oxygen atoms. You remember I talked about this in chapter 8. This releases energy that is to be used to synthesize ATP. So let's go now. So which energy is used to synthesize ATP? Is electrons. I'll show you that. All right, so let me stop here and continue it on the next video so that I just break into two.